Good morning. My name is Steve Moruzzi. I'm the National Training Manager for the Laars Heating Systems. We're going to talk today about the Pennant and MightyTherm2. The sizes we'll talk about range from 500,000 to 2 million BTUs. Now, both of these products are pretty much the same. They utilize the same heat exchangers, combustion chambers, gas trains, igniters, blowers, etc. What changes is on the Pennant is the controls, basically. So the Pennant, we use the Laars Link control. It's a digital display. We'll go through some of that today on some basic troubleshooting, combustion setup as well. The MightyTherm2, I refer to this as point-to-point wiring. Very simple terminal strip. You'll need a voltmeter to go through and check your safety chain, and we'll go through some of that today as well. Now, both products are available in hydronic heating or volume water heating. And the sizes we're talking about today are 500,000, 750,000, 1 million, 1250, 1500, 1750, and 2 million BTUs. We're going to start with product construction. We start with the base and put the back wall on. Next, the front wall. And this is just the right-hand image here is showing the front wall with the openings for your burners, and we'll see all this being built. Next, they'll start by adding some insulation and the refractory block for your combustion chamber. And again, now these orifices or openings here where your burners will come through. Now they'll add the burners. Now the burners are either a 3-bank burner or a 4-bank burner, depending on the size of your boiler. And what we see being installed here today is a 3-bank burner. And those burners are held into position with 4 stainless steel 5/16, or you could also use a Phillips head screwdriver to remove those. Next, we'll have a manifold. And on your manifold are your orifices. Now, these products are available in both propane and natural gas. So you would have different orifices for obviously LP or natural. The manifolds are held into position with 4 more stainless steel screws that actually bolt to the burner themselves. And now you'll see that the orifice is slightly recessed inside the burner. And this is just another image of a couple of manifolds being installed. On CSD1 products, you'll also have a union and a shutoff valve. So if you ever had to take them out, you could break the union, remove your 4 stainless steel screws for the manifold, pull that out, and then remove the 4 stainless steel screws for the burner and slide those out. If you're non-CSD1, you will not have the union in the lower deck. That comes up through the upper deck, and you would have to disconnect that from the bottom half of the gas valve, which is held into place with Allen screws. Now, also on the construction, we do have a sight window. That sight window is down in the lower right-hand side. So you could look in and see your flame pattern. If you ever had any questions with that, you can look into the heat exchanger or combustion chamber area and look at your flame pattern. Now, next I want to talk about is the heat exchanger. There are a couple different materials we use. Copper fin. So this is a fin tube design heat exchanger. We're showing copper fin tubes here. And we also have this in Cooper nickel for volume water heating. Cooper nickel is a harder material. So if you had a volume water heating application where you had hard water, you could install a hard water pump. And that hard water pump would force the velocity through the tubes to keep those tubes clean. That way you don't lime up a tube. So again, on V models or volume water heating models, that would be Cooper nickel. So the heat exchanger, they'll line up the tubes. They'll put the header plates on. They'll pressure test everything and then put the inlet-outlet headers on, as well as the V-baffles. The V-baffles sit in position over the grooves. And what they're there for is they want to be able to absorb the BTUs traveling through these fins. So if you put 2 fins side by side, you don't want all your flue gases traveling through the fins. You want to be able to wrap around those fins or around those tubes and then out the gap. Why I bring that up is if you ever have to clean a heat exchanger, you don't just want to clean the bottom of the heat exchanger. You want to take the V baffles out of position or the baffles out of position and clean the top, bottom, and in between as well. On the product construction, so they pressure test the heat exchanger, and here we're showing one with a pump volute on it. So on the return header, they've added pump volute, so it was being ordered as a pump-mounted boiler. So again, they pressure test. They use an overhead crane, so you can see some cables here to bring those over into position, and then they drop those and set those into position on top of the combustion chamber. So here's your image of your burners being suspended in position. Firing takes place in the chamber and then up through the heat exchanger. Next, they'll add the top plate. Now, I mentioned your gas train comes through the upper deck. There are rubber grommets on here. Why? Because this is a plenum. We're actually blowing air, so there's an opening right here. What they're building is probably a 500,000 or a 750, could be even a 1 million. It's got a single blower. And so you're going to blow air pressure down into this chamber. There'll be a cover door that goes over this. So you want to make sure this chamber is tight, and that's why even the chamber is gasketed. Okay? So we have the upper deck, and then they also add the flue collection. The flue collector is where all your flue gases come into and then out your breeching. Now, to measure combustion air, so we'll have two pressure switches. We do not want to go into ignition if your combustion air fan is not running or working. So again, we're blowing combustion air down into a chamber, and we have we have a barb, and I'm showing the side view here. So that barb will have a vinyl tube that goes off to an air pressure switch. That air pressure switch is normally open. So air pressure closes the switch, and then we'll go into the ignition sequence. Now we also have another barb up here, and that's on your flue collector. Okay? What that is, that's for blocked vent. So if you had a blocked vent or a high wind condition, that is a normally closed switch. So a high wind condition, I'll use as the example, would open the circuit, shutting the boiler down. Once the wind subsides, that circuit closes again and will refire the boiler or water heater. Next, they'll add the fiberboard insulation over the heat exchanger in the combustion chamber and around the flue collector. Next, they'll start adding the gas valves. The right-hand image here, I'm showing something greater than a 1,250,000 BTU boiler. How I know that is we have two blowers in this. Now, we have a common gas train that comes through the top of the boiler, and that could be piped either left or right-hand configuration. There'll be a cap on one side. It all depends on how you order it. If you order it right-hand, then your cap would be on the left-hand side. So that's a common gas train that comes out and feeds down to each gas valve. And we'll talk about measuring incoming gas pressure in this presentation. Next, they're going to add CSD1 controls if it's a CSD1 boiler. My example here is a low gas pressure switch and a high gas pressure switch. They'll add the cover plate for that chamber. I referred to this as a plenum. And then we'll have two little sub panels. What are those sub panels? We use hot surface igniters on these. So instead of having to pull off the whole cover, it's simply 6 screws, and you can gain access to your igniter if you need it. Now also, you can do optional factory mounted pumps. Now I forgot to mention that both of these products can be installed in indoor or outdoor applications, so they're weather tight. And with pump mounted, we'll even add the cover over the pump. So you can order these with pump or less pump. Now, pump mounted, we serve the heat exchanger plus 30 feet of full-size piping is how it's listed. That means we're going to cover the head loss in the heat exchanger plus 15 feet out to the system and 15 feet back. So if you have a hydronic system, hypothetically, primary, secondary, again, 15 feet out to the system loop and 15 feet back. V models for volume water heating, maybe you have a storage tank, that's going to be sized for 15 feet out to the tank and 15 feet back to the body. If you have further distances, please reach out to applications and they will help you size the piping for additional footage. Now, combustion air fans. These fans have two sets of windings in them. Hypothetically, if I'm going to run the left half of the boiler, this blower will come on at full speed. So there's high and low. The second blower would run at a lower speed. Why? Because we want to keep some air pressure down in that right-hand portion of the chamber. If we had a high wind condition that contained some flue gases in the vent without tripping the switch yet, we don't want those flue gases traveling back through an unfired burner and into the combustion air for the plenum area. So they'll run the second blower at half speed. Now, also on these blowers, we'll have a combustion air damper. So when we go through combustion setup today, this will need to be adjusted. So for combustion setup, for all of these products, you'll have to go in and measure and adjust, if needed, your gas pressure for each valve with a combustion analyzer. Now you're going to measure for CO2, and the only thing left is to adjust your air shutter. If you have a single blower, fine, just open or close it as needed. We'll talk about that. However, if you have two blowers, you want to open both blowers equally. Excuse me. The CO2 has to be at full fire. That means all gas valves are energized. So again, you want to adjust your air shutters equally. We'll go through all of this today. We also have a washable air filter. Now, the image in behind here on the Pennant boiler, you can vent in combustion air off the top or the back. On the MightyTherm2, currently it's only off the top. So combustion air, again, you can put this filter box up on top. There is a plate up here. Remove the plate, put the filter box up, and then put the plate on the back side. So we filter the air, and we also have a collar here for ducting. You can duct your combustion air to the outside. So combustion air comes through the filter into the blower down into the plenum area for combustion air. These are also considered a positive gas train. What that is anytime a gas valve's energized, whatever you set your manifold pressure to, every time that valve's energized, that's what it's delivering. So each gas valve would be set up, in this example, 2.5 inches of water column. What's left is your combustion air, and that's why you would have an air shutter adjusting your CO2s. Now, also in the past, we've seen a lot of jobs out there being used for, in the middle of the winter, install for a building, and they need temporary heat. And a lot of times they'll take the front cover off the boiler. What happens? We're no longer filtering the air. So all of that construction dust is coming right in the front of the boiler, into the blower, down into your blower deck, and below your blower deck, and into your burners. So keep that in mind. If you're running these boilers, that front cover needs to be on so we can filter the air. Now, air intake, we allow up to 50 feet of venting or combustion air with 3 elbows. Or you could take combustion air right from a mechanical room. So again, we have a collar here, and you can vent that or combustion air right to the outside. Now, another note I put in here, we've sold a lot of these to hotels, these type products. Might be in a mechanical room off the pool area. They've got double doors they leave open. You never want to obtain combustion air from a pool area. And I'm referring to where they're drawing combustion air from the mechanical room, not ducted outside. Obviously, that's going to play havoc on anybody's heat exchanger, burners, igniters, and whatever. So chlorine, any type of corrosive chemicals, rock salt, snow removal, snow melt. So you do not want to be out drawing that into anybody's combustion or heat exchanger itself. Now the venting on these, and I mentioned that the Pennant can be either vented off the top or the rear. MightyTherm2 is currently off the top only. There are 2 categories for venting for this product. We can category 1, and that's defined as a non-condensing gas appliance that operates with a negative vent pressure. So we can use, it's basically, we'll call that vertical venting. We'll talk about the vent material that can be used. Category 3 is sidewall venting. So that is a non-condensing appliance that operates with a positive vent pressure because we have a fan. So Cat 1, we can use standard B vent. Again, vertical rise. So as we're heating that chimney liner, we'll refer to this as B venting. What happens? We actually create a greater draft. So we could overdraft the appliance. Why I bring that up is in the manual, it states anything over 25-foot vertical rise, you have to add a barometric damper. Category 3, we can go up to 50 feet with 3 elbows horizontal venting. Now, that vent for category 3 must comply with UL 1738, stainless steel gas tight, such as 29-4C. Why? Because that is under positive pressure. And if you had seams that leaked like a B vent, you could blow flue gases right back into the space. So read the manual on this. Again, up to 50 feet with 3 elbows is allowed. Next, I'll talk about the Ignitor Access, and I mentioned to you about the access panel. So we have the Ignitor Access right here. That's held into position with 2 screws. There is a gasket in behind the igniter. Now, hot surface igniter or ignition, the one we use, these are made by Norton. Some manufacturers will use an igniter and a flame rod. We do not. Our igniter is both used to ignite the product. So again, it glows cherry red. Your filament will go cherry red. And that filament will be in the top of the flame. So we're changing the resistance and we're picking up the grounding signal through the flame. And that's how we do rectification. You have 4-second trial for ignition. So we energize the igniter. That goes through its glowing period, call that 20-second warm-up period, gets cherry red, nice and hot, and then we'll energize a gas valve. We'll go through that sequence today as well. So the gas valve gets energized for 4 seconds. If it does not see that flame rectification, it will not allow it to light. It'll drop back out. Non-CSD1 will try again. CSD1 will lock out. That's a single try for ignition. We'll go through that as well. So Norton makes the igniter, and Norton tells you that resistance to check an igniter would be 50 to 80 ohms. But that's at room temperature. So hypothetically, I'm going to refer to the MightyTherm2. You've got a weak igniter. It's glowing cherry red, but you're not getting your flame sensing, and it drops out, goes into lockout. There's a reset button on the fan wall control that we'll see in a minute. You can press the reset button. Now, however, if it starts glowing cherry red again, gets hot, it's no longer at room temperature. So there's also another way to check these, and that's with an amp probe, and you can check it with amps. That's pretty much what most Laars technicians, service managers utilize is an amp probe, and we're looking for 3.4 amps or greater. Typically, a good igniter or a new igniter starts around 3.8 to 4.2 as your amp draw. So we start getting below 3.4 amps, we're going to start to see ignition failures. Ignition lockouts. They're getting weak. And it's kind of a wear and tear item. Every manufacturer out there that makes this type of product uses hot surface ignition. So again, it's a wear and tear type item, short cycling, gas recirculation, corrosive materials, all of that can play havoc on anybody's ignition point. So keep that in mind. I did mention to you most of the service managers use amp probes. Let me give you another example. You go to a service call and maybe you have a bad pump. You can't fire the boiler, you have to order a pump. Well, while you're there, do a simple Ohms test on that igniter. Now you know if you have, now if you need the pump, then you go to fire the boiler, all of a sudden now it doesn't work. Now you got to order a new igniter. Double check it at that point. The MightyTherm2, we'll go through this first, and we'll go through troubleshooting on the MightyTherm2, and then get into the Pennant. So the MightyTherm2, again, weather-tight cover. This cover plate here is also weather-tight. You would remove the cover, and this is the control system that you would see. Very simple point-to-point wiring. Use a voltmeter to identify your safety chain that's open. We'll go through that. Up to 2 ignition controls. So if you have a product of 1250 or 2 million BTUs, you can have 2 blowers, 2 ignition controls. Your smaller sizes, such as a 500 or 750,000 BTUs, will only have a single ignition control. Now, we use an off-the-shelf 2-stage control. By the way, the MightyTherm2, all of these are 2-stage operation, from the 500,000 all the way up to the 2 million. So it's 2-stage. Your Pennant could be up to 4 stages depending on the size of the boiler. So again, we use an off-the-shelf 2-stage control. Very simple. Your adjustments are made there. Hypothetically, you need 160 degrees out to a system loop. We have a jumper here. It's in yellow on this image. And every boiler leaving the factory will have a jumper on them. Currently, they're a red wire, and that is your TT enabled. Okay, so a hydronic application, you could use maybe energy management or something, gives us a call for heat, and then we're going to operate on the outlet sensor as a 2-stage control. Okay, we also have a manual high limit. Depending if it's a hydronic version or a volume water heating. Volume water heating typically is defaulted at 200 degrees. Hydronic would be defaulted at 210. Keep in mind, these are high limits. These are, safety device. Don't drop them down lower. Keep them maxed out. Example, if I've got a volume water heating application and I'm trying to maintain 140 out to a system, okay? And returning back, or 145 and returning back at 125. Why would I ever set my high limit at 140 or 150 or 160? Crank it up. Let it do its job. It's there for runaway, for example. Something gets stuck open, it's just a safety. So don't turn these down, because you will start to have nuisance trips, high limit trips. Now, I mentioned to you ignition controls, and again, this is on the MightyTherm2. We don't use the Fenwal controls on the on the Pennant. We only use them on the MightyTherm2. We did, by the way, use these on the earlier version, Pennant control. So 500,000 to 1 million, we'll use a single ignition control. 1250 to 2 million uses 2 Fenwal ignition controls. Now, a little bit about the control. Non-CSD1 is 3 tries for ignition, okay? So that gives you up to 3 tries. CSD1, and this is all based on the state that you're installing it on. Some state requires CSD1 controls. That would be a single try for ignition. Okay? Now, I also want to mention to you that we have fan connections right here. So we'll power the combustion air blowers from the ignition controls on the MightyTherm2. So when a ignition control goes into a lockout, hypothetically, let's say we had a weak igniter and it went into a lockout, it also shuts the fan off. Okay. Keep in mind, if we're doing combustion air, you ducted to outside, maybe you're in cold climate, it's 0 degrees out some night, the boiler locks out because of a weak igniter, for example. We don't want to be pulling in 0 degree air and freeze a tube on the heat exchanger. So the fans do shut off during a safety lockout. Now, we also have LED status for your lockouts. There's an LED light on these ignition controls. This control is not the current control that we use. This was an image I had. I did not have a good image of the current control, so keep that in mind. But early example of this, 3 flashes is ignition lockout. So your LED light will give you a flash code 3 times. Okay, so you get that 3 flashes. Now, how do you reset it? Right on the Fenwal control is a reset button. So any lockout you would have, you would reset the control right here. And I'll simulate that today. We have some videos that we're going to show. Okay. Now, the terminal strip is a very simple, again, point-to-point wiring terminal strip. Let me start over here in terminal 10. This is 2 sets of wires, so we'll refer to this as 10 and 10A. and that's your terminal. This is 24 volt common. Any of our solid yellow wires here would be 24 volt common. And that's why this early image that you'll see between terminals 3 and 4 is now a red wire. That's your TT call. So this was a real early image that we have. But there's 2 terminals for 10. There's also 2 terminals for terminal 1, and I'll refer to that as 1 and 1A. And we're going to go through this safety chain to understand safety circuit. Now, I also mentioned to you we have a 2-stage control mounted in the cabinet down on the right-hand side. Hypothetically, you might have something out in the system, maybe even an energy management, that wants to control the stage firing for this product. Very simply, they would wire up right here between stages 1 and stages 2. You would take the toggle switch and drop that to the remote position, not local. However, when you're troubleshooting a product like this, put it back to local and then jump out terminal 3 and 4. That way you're troubleshooting the boiler, not a whole system, okay? We'll go through that today. Right now I'm going to play a video that we have for you. Okay, we're going to troubleshoot the safety circuit. I'm going to start by powering up the boiler, and then we're going to walk through the terminal strip. All right, so I've got my voltmeter hooked up to voltage. I'm just going to clamp it here to hold it in position so you can see it. I want to mention to you, all of our yellow wires here are 24 volt common. So I'm going to start with 1 voltmeter and put it on 24 volt common here on terminal 10. Okay, now there are 2 sets of terminals for terminal 10. Any one of those. The next one over here is 24 volt power. I'm going to come over to my 24 volt power, which is 2 terminals here as well. And I'm going to place it here, and as you can see, I do not have voltage. Okay? So that's telling me that either I don't have line voltage or 120 volts coming in, or I have a blown fuse. So I'm going to double check my power, and in this case I do have power coming into the boiler, but as you can see, I do not have 24 volts between terminal 1 and terminal 10. So what's in line there is our transformer and a bus fuse holder. And for this example, I simply took the fuse out of the boiler, okay? So double check your fuse if that's the case. I'll put this back in, and now we're going to go back to the terminal strip. And I also want to show you, now you can see there's an LED light here on the fan wall ignition control. So I know I have 24 volt power, but we're going to check it anyways. Start with 1 meter lead on 24 volt common. Over here I can either go to terminal 1 or terminal 2. You can see I'm reading 25.1 volts on either one of these terminals. So now I'm very simply just going to walk through this terminal strip. So here you can see terminal 2 reads high limit locked flue. Alright, so that's going to be my next test. There's also something else in the circuit that I'll show you in a minute. So 24 volt common, come over here, I got my power, next terminal over, terminal 2, I do not have voltage. So that's telling me that the high limit blocked flue, something there is open or something else in the safety circuit. So if you have what's called CSD1 controls, a low water cutoff, high gas pressure, low gas pressure, double check those, okay? On startup, that will be tripped on a CSD1 boiler. So in this case, I have a high gas pressure switch and a low gas pressure switch. I'm going to reset my gas pressure switches, okay, and just make sure that I have gas to the boiler. Here are our terminal strips, okay. I mentioned number 10 is 24 volt common with the yellow wires. Terminal 1 brings power in, 1 and 1A. So that goes off to our low gas pressure switch, our high gas pressure switch, the limit, blocked flue, manual reset high limit. Okay, and then back to terminal 2. So what we have here was the open gas pressure switch to terminal 2, which I've just reset. So now that you can see I've reset the gas pressure switch, I'll start at terminal 1, I have it, and terminal 2, I now have 25 volts. I'm then going to go to terminal 3. Here's my terminal 3, I have 25 volts there.
Terminal 4, which says field interlock, okay, I'm going to go there, and I do not have voltage there. This, as it leaves the factory, will have a jumper wire on terminal 3 and 4. However, in the field, you may have an aquastat or energy management may control this. If you're troubleshooting the boiler, remove your field connections and reconnect a jumper lead, okay? Also, what I want to mention to you is we have local or remote terminal here. If energy management is controlling this for the staging, put it back from remote back to local. That way we're troubleshooting our boiler, not the whole system yet, okay? I'm going to put a jumper on my terminal 3 and terminal 4 for call for heat, okay? With the meter, I can walk through it. I have it at 20, I have it here at terminal 3. I now have it here at terminal 4. I then go to my proof of fan. All right, I also have it in my proof of fan. I do want to mention to you, if you don't have it there, okay, you need to check your blower, or, now a lot of times if your air pressure switch, which is right here, is not made, people have replaced igniters, and then they want to test the boiler. This cover has to be on, or all of your air pressure is coming out here, and therefore your pressure switch won't make. Also, when putting it back on, put all of the screws back in, because if I only put 2 screws in, I've got air gappage on the bottom, and all that air pressure is going to come out, and it will not make the pressure switch. So make sure this is back on tight. Okay, so again, we've then checked the proof of fan. Next, we're going to walk across. The boiler still doesn't fire, so I have it here at proof of fan, but I do not have it at my flow switch. All right, that means something's going on with the pump, the coupling, the flow switch paddle. Double check to make sure your pump is running, etc. All right, in this example, I left our pump off, so I'm going to power up our pump. So now, I have my flow switch made, which now I'm going to start going in for a call for heat, okay? Looking at our ignition control, you'll see that single flash. That's telling me my igniter is now being energized. I'm going to put an amp probe on there, and we're looking for 3.4 amps or greater. And now we just lit off. Okay, lastly, I just want to talk about the ignition control and the fault codes. So, as we can see right here, we're flashing 3 flashes. And when you look on the codes here, 3 flashes will show you ignition lockout. It's a manual reset. So here are our codes. 1 single flash would be low air. So there's a reset button right here, that little black reset button right there. That is reset for the ignition control. So I'm going to press the reset button, and now we have a steady on light. Once the fan comes on and proves the fan, and our flow switch and everything else in the safety chain is made, we'll see a single flash. And now with an amp probe, I can put my amp probe on either one of the wires, and we'll see that we're looking, again, 3.4 or greater for amperage, okay? If we don't, that means you have a bad igniter, and that's why we went into the ignition fault. On CSD1, it'll only be a single try for ignition, and that's certain safeties that we would have, high-low gas pressure switches, low water cutoff, etc. On a non-CSD1, would be 3 tries for ignition before it shows a hard lockout. And what I did to simulate this was I very simply shut off the gas valves, and that way I was able to test the igniter and put it into a thermal fault. So that's a very simple test to walk through the safety chain. If you have any questions, please contact the factory at 1-800-900-9276. Thank you.
Now, obviously, this video is one. We also offer, there's roughly 45 to 50 videos that we have on Laars.com and YouTube. So if you're not familiar with that, these videos are out there. I embedded the video in the presentation so we could view it today. Now, that time delay, when I reset the control, the blower came on, and there was a delay before the single LED, before the LED light went a single blink. What that is, that's your pre-purge. So we're going to run the blower, depending on the product, for about 20 seconds to clear that chamber of any residual heat. Then you'll go into hot surface ignition. You've got a warm-up period there. Again, we're looking for amperage or resistance, depending on how you're testing it. So that gives the warm-up period. Then we'll energize the gas valve. You have 4 seconds to prove flame, rectify, and then that igniter drops out. So that's why you saw at one point, it was either 3.4 or 3.7. I think it was 3.4 amps on the first test we showed. And then it dropped out after that. So that was your ignition. Once we've proven flame, shuts the igniter off. We're still in flame sense, and we just keep the burners running or gas valves energized. Next, we'll talk about the Pennant Laars Link display. So on the Pennant, again, same product that you just saw, the heat exchangers, everything's the same, different control strategy. So we'll talk a little bit about the home screen here. Oops, I apologize. So on the home screen, we have set points, and anybody that wants to view the classes for this, we also recorded Laars Link class that's available on the Laars Academy. So I went through all of this as well, but I'm just going to give you a little bit info here on this product. What we're showing here is an image for a Pennant boiler. We're showing 4 stages. So that's telling me that this is a 1250 or greater, showing 2 blowers. In this example, all 4 stages are on. Both blowers are in high fire or high speed. We have a symbol here for the combustion chamber. We're showing 100% flame pattern. We have an inlet sensor, outlet sensor, and we'll even give you the delta T. We'll mention, we'll show that the pumps are on, or the boiler pump in this case is on, system pumps off, DHW pump is off. Now, with Laars Link, we give you more options versus point-to-point wiring. With the Pennant boiler, you'll have things like quick start, configuration, someone can get in and change set points, differentials. We can do outdoor reset. Pump configuration, we can change the pumps, very prime. We can do energy management wants to control a boiler. They want to control it with either 0 to 10 volts DC or 4 to 20 milliamp. We can cascade up to 8 boilers. So with this control, we give you all kinds of options. So that's the difference between the Pennant versus the MT2. Now, I've highlighted the padlock symbol here. We're showing a padlock that's unlocked with the letter I for installer. On the padlock, and I just want to talk about this because when we get into the combustion setup video and service video that we'll talk about, you'll have 3 options here. So lock mode, the padlock would be in red and locked, and obviously no adjustments can be made. Leaving the factory, you'll be in user mode. So the letter U appears in the padlock and it's unlocked. The only thing you can really change in user mode is a set point, maybe the date and time that's up here. So you can get in and change set points, etc. However, the installer, service technician, they want to be in the installer level, okay? And that password is 17. Now they can get in and access to all the parameters and settings that they would need. So next I'm going to get in and talk about the Laars Link display, the safety chain service screen. So we just walked through the MT2 with a voltmeter. You don't really need a voltmeter for this product. Everything's going to be there digitally for you. So we'll get in and see that next.
All right, so the next we're going to talk about service. But before I talk about service, I'm going to give this boiler a call for heat, and you'll see a message box appear. And anytime there's a message symbol, you can click on it. and it will tell you what's going on. Example here, warning, the flow switch is opened. And when I go back to the home screen, that symbol is now in gray. That means somebody identified it or opened that icon, but did not correct the issue. So let's go back in now. Let's go under service, and there's some options here for service. For technicians or starting up a boiler, a commissioning agent, go to Digital I/O. And this is your sequence of operation for your safety devices, such as flow switch, low water cutoff, etc. Whatever is in red, that's where you've lost power, or that's where your device is open. An example, if I make the flow switch, that is your, now everything is made, and now we're actually going into ignition or pre-purge. All right, so
I apologize. I was trying to stop the video there. I wanted to show you something. All right, on this screen, what I'm using here is a simulator for this example. So this is not a simulator for a Pennant. An example of that, we do not have a thermal cutout on a Pennant boiler. We do not have a condensate switch on a Pennant boiler. But the point being, everything is in sequential order here. Flow switch first, low water cutoff, manual, high limit, etc. So I'll continue to play the video.
This is your sequence of operation for your safety devices, such as flow switch, low water cutoff, etc. Whatever is in red, that's where you've lost power, or that's where your device is open. An example, if I make the flow switch, that is your, now everything is made, and now we're actually going into ignition or pre-purge. So again, any device that is open, in this example, I'm using a simulator, I guess through the toggle switch for high gas pressure switch. So you'll see up to the thermal cutout, if the boiler has it, will read thermal cutout. Any device that has to be manually reset, such as a high gas or low gas pressure switch or low water cutout, you cannot just reset it from the touchscreen display or the Laars Link display. You have to physically reset the device and then reset the control. So in this example, I'll reset the high gas pressure switch. However, I'm still in a hard lockout. And no matter what I do here, even if I go back to the home screen, it will be there. So once the device is reset and our blower is off, now you can reset from the home screen. So it'll be locked out in two areas. One is the device, and one is the actual home screen for Laars Link. So again, that's your sequence of operation. That is everything in the safety chain. Again, you'll see messaging, or you can come here to Digital I/O. So we also have the option here for outputs. So we can click on outputs, and it'll give us more information about the system. Right now, we're not running. Why? Because I don't have a call for heat or a TT call. But our system pump's on. DHW pump's off. We're not in an alarm status. Our boiler pump is on. As I give a boiler a call for heat, it'll go through its sequence of operation, pre-purge, ignition, etc. So that is more valuable information as well. I will now click the back button, or again on the navigation bar, I can come right back here to service. Analog I&O will give us even more information, showing an inlet temperature, outlet temperature. If we have a stack sensor in a boiler, it'll show us the flue temperature. Depending on the product, you might only have one stack sensor, or a product like a Pennant would not have a flue sensor. So you can just scroll through. We can see our supply temperatures, return temperatures, outdoor temperatures if we were hooked up with an outdoor sensor. And if the boiler was actually running, we would see a flame signal appear. And now you'll see that I gave it a call for heat. We went through the sequence of operation, and now we're actually getting a flame signal. I'm going to go back to the service menu.
Okay, analog I&O, all of that information is right on your home screen as well. So we talked about inlet temperatures, outlet temperatures, flame signals. All of that is right on the home screen. However, we do have that also under service, so you can view that there. Next, we're going to talk about is combustion setup for these products. Now, combustion setup or startup You know, follow their factory's specifications. I don't care who the manufacturer is. You know, you really need to read that information. And some manufacturers might be looking at O2. Most manufacturers look for CO2 with an analyzer. So again, make sure you're following their procedure. With us, we do monitor CO2. So I'm showing here a digital manometer. That's to measure incoming gas pressure and also your manifold pressure. I'm showing an amp probe, so you could measure amperage as well as voltage. And lastly is a combustion analyzer. Every manufacturer out there, over 84%, tell you you need a combustion analysis done. Okay, so for those that don't have them, you really should be investing in them. It's a great revenue. You can sell that, you know, customer annual maintenance. You'll come back in and do a flue analysis and make sure it's running at optimal efficiency, etc. So you need a combustion analyzer. Now, you'll see on the video I'm about to show, again, we have a single common gas train that comes into each gas valve. And you can use any one of the taps. So you're going to have an Allen set screw on each gas valve. Any one of these you can measure incoming gas pressure. So incoming gas pressure, which we'll see, and I'll talk about that, you're going to have static pressure and running dynamic pressure. Your static pressure, read your nameplate of your boiler, okay, or rating plate of the boiler. We tell you 4 to 13 inches currently. Early version of this product back a couple years ago was 5-inch minimum. So we need to make sure we're within that range of 4-inch water column to 13-inch water column. Also, once you get a piece of equipment running with all valves operating, you want to double check your incoming gas pressure. Example of that, maybe I have 7 inches of incoming gas pressure static. Now I turn on the boiler, adjust each gas valve, go to full fire. I want to make sure that that doesn't drop below 4 inches, okay? So we're going to go through and check each gas valve and adjust them if needed at 2.5 inches of water column manifold pressure. That's downstream pressure, okay? And you'll see this in the video. So you're going to have another test plug like this on the bottom, and that's where you're going to go out and you're going to put your manometer in and double check that as well. Keep in mind, if your valve is not energized, so if I don't have a valve energized and I put a manometer on it, my blower starts up, I could be reading blower pressure from the chamber. Why? Because once we put air into that chamber, it could travel backwards through the burner, into the orifice, up the manifold to the bottom side of the gas valve. All right. So when you're measuring 2.5 inches, your gas valves need to be in the on position. And I did simulate that in the video. So once the gas valves are all adjusted to 2.5 inches, what's left is your combustion air. And all you're going to do is an air shutter. And you're going to close the cover door afterwards once you make an air shutter adjustment. Why? Because you want to be able to, especially if you're ducted, you know, 500,000 BTU boiler, you might have a 6-inch collar and you're ducting 50 feet with 3 elbows for combustion air. That's a vent restriction. With the cover off, you're just pulling combustion air right into the blower and down into the chamber. So you want that extra restriction, especially if it's ducted. And again, you want to adjust 2 blowers, any system with 2 blowers. So that's a 1250 or greater. Adjust these air shutters equally, okay? And go by our CO2 chart. Here is our flue gas reading. Again, I've got it highlighted in red. At full fire, that means all valves are on. Now you can go in and check your CO2 percentage. Natural gas in our example that we're doing on the video is 8%. Propane is 9.2. Okay. I'm going to just go ahead and play the video. As you can see, I've removed the cover. Prior to doing that, I shut off gas and electric. Our next step is check the incoming gas pressure. We need the gas off, and I'll remove one of the test plugs. What I forgot to mention was I'm showing the Pennant combustion setup. The MT2, you're just going to turn up your two-stage aquastat, give that boiler a call for heat, and go through the process. Now, if you've got a 2 million BTU boiler, you can shut off gas valves you're not working on. You don't have to, but in the example, hypothetically, I've got a system loop temperature. It's already running at 170 degrees, trying to maintain 180. You know, you really don't want to overheat that loop, and then you can't keep it in full fire to do a combustion analysis. So in that example, you can shut off your other stages, such as, you know, gas valves 3 and 4. Keep in mind, if you have a larger boiler, 2 igniters, 2 blowers, you will lock out that second stage on a full call for heat. Why is that? Because you don't have fuel. So when you go back to double check those gas valves, you'll have to reset the control. Digitally, we'll do it digitally on the Laars link control as well. So I'm showing you combustion setup on the Pennant. However, MightyTherm2 is going to be the exact same, just less that control.
Now I'll install my barb to measure my incoming gas pressure. This is a common gas drain to each gas valve. And again, we have a test plug on the top of each gas valve. The boiler we're showing here is a 1 million, and it has a CSD1 high-low gas pressure switches off that tap. That's why I chose the middle tap. Next, with my manometer zeroed out, I'll hook up my manometer and turn on my gas. This will show us the incoming gas pressure. So now you can see we have 6.8 inches of water column coming into this boiler. This boiler requires a minimum of 5, maximum of 13 inches of water column.
Now, I just mentioned a minimum of 5, maximum of 13. So the earlier products, we were certified for 5-inch minimum, maximum 13. We were recertified by ASHRAE in 2018 for 4 inches. That was March of 2018. So read your rating plate, which is on the right-hand side of the boiler, and it'll give you that range, minimum and maximum gas pressures. Also, low gas pressure switches, you know, keep in mind, you don't want to turn those down too low. We've had cases where maintenance personnel got sick of having to go in when it was in high demand, call that February, and it would go into ignition, not ignition lockout, low gas pressure switch. So he took the cover off and turned that down to 2 inches. Well, if your gas pressure never drops below 2 inches, it won't trip the low gas pressure switch. So where are you? Now you're in ignition failure, and technicians were chasing the wrong problem, replacing igniters, dialing in CO2 2 or 3 times. Everything was fine, and it turned out to be the gas pressure under high demand was dropping below your rating plate. Okay?
So at 6.80 inches of water column, that should be static gas pressure. None of my valves are on the boiler. Static is the gas pressure sitting idle. We also want to run another test when we're done with all valves running to make sure that this gas pressure does not drop below 5-inch minimum. Now I'll turn the power back on to liven up the display. The display will go through its booting synchronization process. The blower will kick on for a few seconds as a pre-purge. And now we're at the home screen. So right now we're in U, which is the user padlock. For this, I'm actually going to go back into my padlock. I'm going to log out, which is now the padlock's locked. I'm going to log back in with number 17. That is it for our installer password. I click enter, and now you see the letter I on the padlock, and it's in green showing the padlock symbol open. Now I'm in installer mode, so I can go into the parameters. So I want to give this boiler a call for heat. B1 and B2 is in standby. My stages are all off. Blower is all off. Currently, I'm showing an inlet temperature of 69 degrees and an outlet temperature of 70 degrees with a delta T of 1 degree. Okay? Boiler's firing or fan speed at 0%. I will give this boiler a call for heat. So the very first thing we'll see is lockout. So it's telling us the boiler's locked out. I haven't called for heat, but I'm in lockout. It says reset. You can reset it there, but it's telling me what the lockout is low gas pressure switch. Even if I reset it there, it will not fire the boiler. The reason is, my low gas pressure switch, which is right here, is in lockout. When we leave the factory, we test fire each boiler, but we obviously remove gas. If you're a CSD1 that has high and low gas pressure switches, this will be tripped. If you're non-CSD1, you will not have these controls. I'm going to reset it here, come over to my touch screen and reset it here. Now I also want to mention, if this blower is running, I would not be able to reset it. I have to wait till the blower times out. Okay? So now we go back to here, and we'll see that we have a calculated set point of 160. Our blower is in pre-purge, or V1's in pre-purge, now HSI. That's the hot surface ignition warm-up period. We can take an amp probe and do a test on that. So coming down through the upper deck is a hot surface igniter wires. You may not have these Molex plugs on them. This is in our test lab. I'm going to put an amp probe on it. We're going to wait for us to go through pre-purge. So currently we're in pre-purge. It's going to tell us everything that's going on with the boiler. Once we pre-purge the chamber, the next thing that will happen is we're going to HSI, hot surface ignition. Yes, as you can see, we're running about 3.5 amps. A good igniter runs between 3.4 and 4.2. If you have a weak igniter, you want to replace it anything less than that. Before I actually go and check all of my valves, there's going to be an interstage delay. And that interstage delay, I want all three valves coming on. In this case, we're running a 1 million BTU boiler. I want all three valves coming on. So now I'm going to go to configure. Central heat set point, I'm going to choose first stage, first one. And as you can see, we've got some of the set points here. Under additional settings, I can get in and set my stage delay on time. Again, I want each gas valve to come on quickly, or fairly quickly. This should be defaulted around 60 seconds. I'm in the installer password. If I was not, I can't change it. And again, I drop this down to 20 seconds. You can simply increase or decrease. I would at least give 15 to 20 seconds between stages. Why I'm dropping this down is we don't want to preheat our building loop and take too long. We may not be able to stay in full fire. Combustion testing is only done with all gas valves on. So I've dropped that down to 20 seconds. Click enter, it's going to allow it. Again, if I had it here at 1 to 21, if I click enter, click OK, I'm going to go back in again and drop this back to 20. Click OK. And now my stage on delay time will come on in 20 seconds, every 20 seconds once we fire. I can go back to my home screen and now we'll watch the firing. I'm going to give this a call for heat. So, as you can see, stage one is on. We're firing at about 30%. This is a 1 million BTU boiler. I want all three valves in the on position to do combustion test. Stage 2 is coming on. Stage 3 should be firing shortly. It's showing V2 on the HSI warm-up. And now stage 3 is on. We're at 100% of fire. Now we can do combustion testing. However, one thing we have to do first is test the manifold gas pressures. Measuring the manifold pressure is done at each gas valve. We'll shut off all of the valves except for the one that we're testing the manifold pressure at. And there's two ways of turning the valves off. One is by the touchscreen display, which I'll show you first, and then the second way is by manually shutting the gas valves off. Why we typically use the digital display is if you have a larger boiler, greater than a 1 million BTU boiler, it will have two sets of igniters. If we shut it off digitally, it won't lock out that second half of the boiler. If we shut it off manually, it may lock out the second half and you would have to reset it. So the digital way, we'll go in under service, press service, and the first option here is burner. Press burner. And this boiler is a 1 million, so I have 3 stages. If you have a 2 million, you're going to have 4 stages, etc. Maybe only a 500, a 750, only have 2 stages. So we can go in and shut off each stage. For this example, I'm going to shut off stage 3 and stage 2 to check my manifold on stage 1. Once I press disable, press the back button. It's going to prompt you to choose OK. Press OK. And now I'll go back to my home screen, and you'll see that stage 2 and stage 3 is off. Only stage 1 is on. However, I'm going to go back in here again, service, burner. I'll enable these stages for an example. And if you only have a single stage boiler and you choose to shut off valve 1, it automatically will shut the other valves off. Okay? You should be able to go in and with this it has 2 igniters. So if you've only got 1 igniter and you've got a 2-stage boiler, so only stage 1 and 2, the igniter is under stage 1. That's why when we tried to change it, it changed both stage 1 and 2.
So I'm going to stop the video and explain again. So your igniter is under stage 1, and a 4-stage boiler, your second igniter is going to be under stage 3. So if you tried to shut off stage 1, it automatically shuts off 2. Why is that? We don't want to energize or try and enable stage 2 where there's no ignition point, and the same for stage 4. You don't want to try and enable stage 4 where the igniter is under stage 3. So that is the only other thing that could be a little confusing. You don't have to go in and shut these gas valves off. You can leave it running at full fire. The only time you may have to is, like I said, if your system loop or if you've got a volume water heating application and your tank temperature is coming up pretty quick, you want to be able to give the boiler a nice run time so you can do a combustion analysis. I'll continue to play the video.
So that is the example. Again, I'm going to go back in to burner. What I want to do is enable valve 1, valve 2, and 3. I'm going to shut off in this example. And that way I can test manifold pressure on valve 1 with my digital manometer zeroed out. If I have CSD1, I'll have this butterfly valve set up. I've already put this barb in for my manometer. If not, you're going to remove the test plug on the bottom side of the valve and install your barb. Make sure your manometer is zeroed out. Now you can install the barb. I'll open the butterfly, and I'm looking for 2.5 inches of water column. As you can see, I'm running about 2.4 to 2.5, which is good. A couple of tenths is not a big deal. If not, here under on your gas valve, there'll be aluminum cap. Take the cap off, make an adjustment with your screwdriver. When you're done, the aluminum cap should go back on. So now valve 1 is checked and set. I have to do this for all 3 valves in this case. I'll enable valve 2, check that one, and then we'll come back into this option and enable valve 3. With the second option, we'll go in and manually shut off valves 2 and 3. I'll open the butterfly, and I'm looking for 2.5 inches of water column. So now valve 1 is checked and set. remove my hose, come over to valve 2. Zero out my manometer again. And open my butterfly. Now, you'll see that I'm not reading 2.5. The reason is I shut that gas valve off. What I'm getting is a pressure reading from my burners through the manifold, okay? I will energize my gas valve, and now you'll see I'm reading positive 265. In this case, I will go in and I will make a slight adjustment. Now you can see I've set up between 2.4 to 2.5. It's going to bounce around a little bit. Again, it's a couple of tenths, it's not a big issue. Lastly, I'll shut this valve off, and I'll go to my third valve. I originally shut these valves off. You can leave them on, but keep in mind you may preheat your loop depending on the time of the year and what your building demand is. Also, if you shut these off in stage 2 with lockout, it'll read lockout. In that case, turn your valve back on, get the reset on the screen, wait, and you'll then see. So in this case right now, stage 3 is in the on position, and I can check my last valve. I'm zeroed out. I'll go to my manometer, open the butterfly, and you'll see I'm reading between, well, at 2.4 and 2.5. We can make a slight adjustment. Okay. With the valves adjusted, what's left? Combustion setup. With all valves in the on position, on, and on. Again, this is a 1 million BTU. We had a 2 million, there'd be 4 stages of 4 valves. We're reading 100%. I can now do my combustion analyzer. I'm going to turn the pump on and install it in the flue. What we're looking for is CO2. So as you can see, we're pretty close to 8% CO2. You can make adjustments, very simple. Next is on that air shutter. If we have our gas valves all set at 2.5 inches of water column, it can be either natural or propane. It has to be at 2.5. This boiler I'm running natural gas, so my CO2 on natural gas is 8%. I can either open or close my air shutter, okay? You can loosen the nuts on the bottom part of the blower. However, you really just need to tap on it one way or the other to make your air shutter adjustment. When you're done, my suggestion, take black magic marker and put a mark there. Now you know on the day you started it, your CO2s and manifold pressures were correct. Now when you're making an air shutter adjustment, put the cover back on if you're ducted outside the building. If you've got a 6-inch vent collar or 7-inch vent collar, you want to be able to restrict that air. You don't want free air coming right in here to the blower. So again, when you're making combustion adjustments on the air shutter with your analyzer, if you're bringing combustion air into the boiler, put the cover back on.
So all of these videos are available at Laars.com or on YouTube. So we do have a YouTube link right there on Laars.com. If you need any technical or applications assistance, please call 1-800-900-WARM. Product support is prompt 41. Application support is prompt 72. And part support is prompt 71. All of the information is available on Laars.com under document download. So you can pull up the manuals, some products we have startup guides for, etc. Thank you.